Okay, so this lesson is going to be about advanced content, and it's going to be content that you actually see in year 9, and it's all about expanding binomial products. Now, the first thing I have to say, which is very important, is that this is not going to be assessed because it's year 9 content. But the reason why we're going through it is because it provides us a really great opportunity to extend our thinking and to provide you with a bit of a challenge. Okay, so let's go through our learning intentions. To know how to apply the distributive law to binomial products, to be able to expand and simplify binomial products. So let's begin by just building up our understanding before we launch into the content itself. And we're going to build our understanding by looking at some rectangle area. So here the instructions are: write 2 equivalent expressions for the area of each rectangle shown, only one of which includes brackets. So we're going to write 2 expressions that represents the area of this rectangle. So 1, 2, but only one of those expressions is going to include brackets. Now the first way we could do it is to treat this as one area, which we'll call A1, and treat this as another area, which we'll call A2. We could then add A1 and A2 together to find the total area. To find the area of A1, it's just width times length, so 2 times 5 is 10. To find this one, again, width times length, so 2 times x is 2x. And now I will just plus those together, and this expression represents the total area of this rectangle. The other way to write down an expression for the area of this rectangle is to treat it as one thing, just one thing like that. To do that, we're again going to use width times length. The width of this entire rectangle is 2. The length of this entire rectangle is a bit trickier. As you can see, I have this which is 5 and this which is x. So the entire length is going to be 5 plus x. So I would say it's 5 plus x. And remember, we don't like writing in that multiplication sign, so we'll just write it like that. 2 brackets 5 plus x. Perfect. And what we have previously seen is that these two things are equivalent, and we know how to kind of change one into the other. So for example, if I was to expand this out, so remember these arrows, 2 times 5 is going to be 10, 2 times x is going to be 2x, and that is what we have up here. Or if you wanted to, I could factorize this. I could take 2 out, and I'd be left with 5 plus x, like that. And that is what I have up here. So that's really just proving to you that they're the same. They're equivalent expressions. Okay, let's now move on to what we're talking about here, which is how we can do the same thing. So write 2 expressions for the area of this rectangle. But as you can see now, I have 4 areas. So again, we're going to write 2 expressions here. The first way I could do it is simply by finding each of the sections and adding them together. So the area of this part right here would just be x times x squared. The area of this would be x times 3, which would be 3x. The area of this part would be 2 times x, which is 2x. The area here would be 2 times 3, which is 6. And then I would just have to add all these together. 3x plus 2x is 5x, so I have to gather those like terms. So I would do this, 5x plus 6. And there's your answer. So that expression represents the area of this rectangle, and we found it by finding each of these individual sections and adding them together. The other way we could write an expression for the area of this rectangle is by considering this entire width, which is x plus 2, and multiplying it by this length here, which is x plus 3. So if I go x plus 2 times x plus 3, that's going to give me the entire area. And remember, we don't like that multiplication sign. So a better way to write it would just be x plus 2, x plus 3. So what we now have to learn is, how is this equivalent to this? That's what we need to figure out. How are these two things equivalent expressions? All right, so again, the way we're going to show this is the same way we showed it up here. So up here, the way that I showed that this was equivalent to this was by expanding. And that's what we're going to do now. We're going to expand. We're going to go x times x is x squared. X times 3x is 3x. 2 times x is 2x. 2 times 3 is 6. As you can see, let me get out my highlighter. X squared, 3x, 3x, 2x, 2x, 6, 6. If I now were to gather up my like terms here, I'd be left with x squared plus 5x plus 6. This is the same as this. So they're equivalent. So we're using this expansion, and this expansion right here is what this lesson is all about. For our last example here, let's not write two expressions. Let's just immediately write down the expression with brackets. So what I'm going to do is I'm going to take this length right here, which is going to be 2x plus 3, and I'm going to multiply it by this width right here. So it's going to be x plus 1. So that means I'm going to get 2x plus 3, and then I'm going to get x plus 1. Now, I can expand it. So I can go 2x times x, which is 2x squared. And that's the same thing as going 2x times x, which is 2x squared. I can then go 2x times 1, which is just 2x. And that's the same thing as finding 2x times 1, 2x. So this area right here. Then I would go 3x times x, which is 3x. And that's the same as going 3 times x, which is 3x. Then I can go 3 times 1, which is just going to be 3. And that's the same thing as going 3 times 1. 3 times 1 is 3. And as you can see, I found the entire area. I then have to make sure that I gather my like terms, because 2x and 3x is 5x. And there you go. That's what this lesson is going to be all about. Here is just some theory. So it says expanding binomial products. The reason why it's called binomial is because we have two terms. So as you can see here, we have one term, we have two terms, and then we're multiplying it by another binomial, one term and two terms. So it's binomial products. We're timesing things together which have two components. And you can see these very important arrows. These arrows are what it's all about. Remember these arrows. And if you're ever trying to conceptualize what we're doing, you can look over here and you can say, all right, I'm finding the area of a rectangle. Okay, let's now get into the actual maths. So let's expand the following. All right, so the way that we do this is you go x times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15. You then gather the like terms. So in this case, 5x and 3x is 8x plus 15. That is your answer. Let's come here. We're going to go x times x is x squared. X times 7 is 7x. Now, negative 4 times x. Negative 4 times x is negative 4x. Negative 4 times 7 is negative 28. So I'm now going to gather my like terms. 7x minus 4x is plus 3x minus 28. That is your answer. Let's keep on going here. Next. And you might just want to pause the video right now. Pause the video and see if you can answer these two questions, and then hit play and see if you get them right. So pause the video. All right. Hopefully you pause the video. So now I'm going to answer it. 2x times x is 2x squared. 2x times negative 6 is negative 12x. Negative 1 times x is negative x. Negative 1 times negative 6 is positive 6. Then I'm going to gather the like terms. This is going to be negative 13x. This is going to be plus 6. That is going to be my answer. We come over here. Again, maybe you want to pause the video. Give it a go. Here, the way I'm going to answer it is 5x times 3x is 15x squared. 5x times 7 is going to be plus 35x. Negative 2 times 3x is going to be negative 6x. Negative 2 times 7 is going to be negative 14. That means after I've gathered like terms, it's going to be 15x squared. This is going to be plus 29x minus 14. That is my answer. Let's now answer the last two here. Again, I want you to pause the video, give them a go, and then see if you get it right. If you're just mindlessly watching me, it's the worst way to learn. You want to give it a go and then review what you've done. All right, so again, we're going to go 4x times 3x, which is going to be 12x squared. We're going to go 4x times negative 4y, which is negative 16xy. We're going to go negative 3y times 3x, which is going to be negative 9xy. Then we're going to go negative 3y times negative 4y, which is going to be positive 12y squared. We're then going to gather the like terms together. Negative 16xy minus 9xy is going to be minus 25xy plus 12y squared. Let's now answer our last one. We're going to go this times this, which is going to be x, y, z. This times this, which is going to be plus 3x squared y. Then we're going to go this times this, which is going to be negative yz squared. Then this times this is going to be negative 3xyz. Yes. We're now going to gather our like terms. Now, where are our like terms here? We had x, y, z, x, y, yes, yes. Which ones are like here? Oh, there they are. They were hiding from me. This is like to this. So that means I'm going to get negative 2xy there. So you just got to kind of keep your eye out there. I'm going to get negative 2xyz. Sorry. So this one and this one are my like terms. And that means I'm going to have this one by itself. And then this one by itself. And that's your answer. Perfect. That is expanding binomial products. Hopefully you found this interesting. I'll provide you a little activity for you to practice this skill. Let me remind you, this is Year 9 content, so it will not be assessed this year. But hopefully this has pushed you a little bit. And most importantly, I really hope that you conceptually understand what's going on here. And with that, I will see you in the next lesson.